All right, so today we're going to do the difference quotient, the average rate of change using the difference quotient, and then the average rate of change on an interval, again, using the difference quotient. These, I'm only going to do 2 problems, but I do want you guys to give me these when you come to class. So you guys are going to turn these in right when you come to class. Don't do it in your notebook if you use a notebook. Do this on a piece of paper that you can turn in. Please just put your name on it and give it to me as you're walking in the door. Okay, so we're gonna do the difference quotient. I'm gonna remind you guys that I'm putting the date that we're gonna use this in class and not the date that I'm writing it. So I know that today is not the 17th. That's the date that we're gonna use it in class. I don't know if that's more or less confusing, but that's the way that I'm doing it. So this is the day we're going to use it in class, which is Friday. So the difference quotient is like your slope. Actually, technically the slope is a difference quotient on a linear function. But the thing is that if you look at a linear function, it doesn't matter where I'm looking at the function. From here to here, the slope is the same as from here to here, okay? But if I'm looking at like a quadratic or something like that, the slope changes over time. So the slope from here to here is different than the slope from here to here. So it's very visually obvious that these are different slopes, but they have the same difference quotient. So the rule for finding the slope is always the same. So the difference quotient, we do this. We do f of x plus h minus f of x over x plus h minus x. So what you're doing on a normal linear function is you're doing y minus y over x minus x. The change in y, which remember that your f of x is the same thing as y. So all that I'm doing to go from here to here is I'm adding some number. It doesn't matter what that number is. I'm just saying I'm going to add some number. So when I add that number, I have to subtract away the difference in the y. So that's what this guy means, the difference in y. Over, I took the x and I added some number to it. So when I did that, that changed the x value. So I have to subtract those away, which is the change in x. So that's what you're doing anyways, but we're doing it with functions now instead of with like points. We're going to do it with actual functions. And we are going to do it with points as well. So that's what we're looking at there. So, sorry, when I have this, what some people are going to notice is that the denominator can be simplified. And this is always going to be true. So instead of remembering this rule, we're just going to say x minus x is nothing. So it's just over h. So that's going to be our difference quotient. Okay, I'm going to leave that right here so that I can do like a linear function. So if I have something like f of x equals 2x plus 1, this is f of x. F of x plus h means that I take the x and I replace it with x plus h. So f of x plus h is 2 times x plus h plus 1. F of x plus h simplifies to 2x plus 2h plus 1. So now I'm going to plug it in. So this piece is right here, 2x plus 2h plus 1 minus this piece is right here, 2x plus 1 over h. Now I'm going to simplify. So I have 2x minus 2x. That's nothing. I have 2h, no other 2h's. I have 1 minus 1. That's nothing. So really I have 2h over h, which is just going to simplify to 2. So the difference quotient for this one, or the slope at any point on the line is just 2, which we could tell that from just looking at this function right here. So that makes sense. Okay, now doing it with something that's a little bit different, like a quadratic. If I'm doing it with a quadratic, I'm going to have like f of x equals x plus 2 squared plus 3. So the first thing I'm going to do is I'm going to replace that with x plus h. So I'm going to have x plus h, x plus h plus 2 squared plus 3 minus x plus 2 squared plus 3. I'm going to put that in an extra set of parentheses because the whole thing's being subtracted, and I might as well do that right here too, over h. So I'm going to have to expand this out, which is going to be a pain in my butt, but I'm going to do it. So x times x is x squared, x times h is xh, x times 2 is 2x, h times x is hx, h times h is h squared, h times 2 is 2h, 2 times x is 2x, 2 times h is 2h, 2 times 2 is 4. So that's this whole first part. So x squared, combining like terms, plus 2xh plus 4x plus 4h plus h squared plus 7 minus, expanding this out is going to give me x squared plus 2x, so plus 4x, plus 4, plus 3. Hopefully you guys are able to expand a binomial. If not, we're going to have some real trouble this year. But I will help you with that if you need help. So I have x squared minus x squared. Those cancel out. I have 4x minus 4x. Those cancel out. I have 4 plus 3, which is 7. 7 minus 7, so those cancel out. So I'm left with 2xh plus 4h plus h squared over h. I can factor an h out of each of these, which would give me 2x plus 4 plus h over h. And those are going to cancel out. So this is going to have a difference quotient of 2x plus 4 plus h. So that's my difference quotient. Okay. Now, if it told me to find the average rate of change, that is the average rate of change. The difference quotient and the average rate of change are really the same thing. But if it told me to do it over a certain interval, like it told me to do it over the interval on this example, let's say that it told me to do it over the interval of 1 to 3. Now, I would do that from the beginning instead of from the end. And what I mean by that is, in this example, x equals 1. The difference between these two is h, because remember, this is x and this is x plus h. These intervals need to be included. So it needs to be like that. The intervals should always be included on these guys. Sorry about that. So to get from 1 to 3, I added 2, which means h equals 2, okay? Now I can do it at the end if I really want to, but I feel like it's a little bit easier to do here. So if I was going to do it at the end, I would go 2 times 1 plus 4 plus 2. So 2, 6, 8. But I feel like it's a little bit easier if I just start at the beginning. So if I start at the beginning, I have this right here, and I can find f of x plus h by plugging in the 3. So 3 plus 2 is 5 squared is 25 plus 3 is 28 minus f of x, so plug in the x. 1 plus 2 is 3, 3 squared is 9 plus 3 is 12 over the difference between these two. So 3 minus 1 is 2. So that's going to give me 16 over 2 equals 8. So it gives me the same value. It's just, oops, I'm off the screen. It gives me the same value. It's just two different ways to do it. Hopefully that makes sense for you. Hopefully you can do those two problems. We'll see. This video is getting a little bit long, so I'm going to stop.